Scholars, welcome back to a live CSEC math class, and this is the Kemet Maasai Academy. Tonight we're going to be looking at sets. We're doing an introduction to the topic set. So this is our topic by topic session. And I'm going to now share the link so others can join us. In the meantime, get your books and pencils and be ready. So sets is a very simple and straightforward topic. And we're going to look at the definitions, the terms that are used in sets, and look at some examples of sets. Okay. All right, so let me share the screen now so we can bring up our presentation.
Mr. Consider the introduction of sets. Yes, I was asking if we consider the introduction of sets first.
Yeah. So you're going to reading for me.
Yes, miss.
Yes, miss.
All right, so there we're waiting for our screen to come up.
Miss, I can see everything actually. Miss,
It
could I
takes
read
some
it?
time. Hold on. It's not. So why can it so long?
This is the part where it says I said I said can be null.
Are you seeing it on the screen?
Yes, miss.
But I'm not in it. So why would it want to leave me out?
Miss, I can also see it.
Okay. Oh Lord. Why is it doing this to me tonight? We're done. Let me try again. Stop sharing. Lord help me. Come in, John. Let me see if I can really see it. Because I'm not seeing it on my screen.
A set is a collection of objects.
John.
CSEC math set. Okay. CSEC math set. A set is a collection of objects that have at least one thing in common. A set can be empty, null, finite, or infinite.
Okay. All right, so a set, by definition, a set is a collection of objects that have at least one thing in common. And it also said we can have finite sets, infinite sets, or null sets. All right, so the finite set, and we're going to explain that a little further down. The finite set is where you have, you're able to list all the members and or all the elements of the set. The infinite set is where you are not able to practically or realistically list all elements in that set. And the null set, which is otherwise called the empty set, is a set that has no possible members. So this is one of them that people can go, people can go all out and think of the most outrageous things that they can think of that's not possible for anyone to be a part of and be into null sets.
Yes, Miss.
All right, what does
Miss example for null set is that Miss is even numbers between 11 and Miss between 11 and 11.5.
All right, even numbers between 11 and 11.5, correct? Because there are no even numbers between 11 and 11.5. All right. Or people generally tend to get more outrageous than that when they think of the null sets, right? So they would say things like boys who have 10 feet horns, or people who have swum across the Pacific Ocean, something which is just not possible, it is never achievable, that kind of thing. All right, Imani, read the next slide for me.
Okay.
Good night to those who are just joining on the chat. Denise, welcome. Zion, welcome. Dinah Moore, that's a lovely name. Okay, Imani, go ahead, read.
Okay, Miss. Examples of set. A. Miss, that's the correct slide, right?
Mm-hmm.
Okay. Examples of set. A equals the set of prime numbers less than 10. So Miss, they have A equals 2, 3, 5, and 7.
All right, so this is showing you different ways that we can write sets. Okay, so we can actually write out word for word and describe the sets, or we can give a more abbreviated description using a capital letter to represent the sets. So using our curly brackets as well to enclose the elements in the set. Prime numbers less than 10, so that's a description of the set. Or we can just write what the actual prime numbers that are less than 10 are. So we'd put set A equal, put your curly brackets, 2, 3, 5, 7, close your brackets. Those are the prime numbers that are less than 10. So we're alternating. John, your turn.
Okay, Miss, which one am I supposed to read?
The one
Okay.
that's up.
Yes, Miss. I see it now, Miss. Elements. The members of a set are called elements. For element A. For is an element of A. Member of set A.
All right. So to say that something belongs to the set, is a member of the set, we say it is an element. And we would write, whatever the thing is, would write that, and it's an E, but it looks like a curved E, the symbol for element. It's not a capital E as the one I have here. It's more curved. So 4 is an element or member of the set A. Okay. Imani?
Okay, let's. All the elements being considered for a particular situation are collectively the universal set. The universal set is represented by a capital U.
All right. So remember we said that the set has elements that have at least one thing in common. Now the universal set refers to all the elements being considered in a given situation. So everybody being considered is part of the universal set. And then we're going to have the different sets now where those elements, whatever they have in common, they will be placed within those particular sets. Sometimes you can be a member of the universal set, but not a member of any of the smaller sets within the universal set. And we'll see in just a little while when we draw the Venn diagram to represent sets. The rectangle represents the universal set, all the elements, and then the circles within the rectangle represent the smaller sets. And sometimes you have elements that are not in the circles, but they are in the rectangle. A capital U is used to represent the universal set. John?
Okay, miss. Examples of universal set. Universal set. 1. Students at Kemet Maasai Academy. Grade 4. Students. Jamaica music. Reggae music. 3. Months of the year. Month starting with J. Make sure I say the months that start with J.
All right, so these are examples of universal sets, and then examples of a smaller set that might be a part of the universal set. So if we're saying the universal set, students at Kemet Maasai Academy, that's the broad set, all the elements being considered. Now we might say, okay, we're just thinking about the grade 4 students or the grade 6 students. So each of those would be a circle within the universal set. And those two circles will not overlap because there are no grade 4 students who are also grade 6 students. However, you might have some circles that overlap. If we talk about, for example, students who carry black bags, some of the grade 4 students might carry black bags. Some of the grade 6 students might carry black bags. And so each of those would intersect with the set for black bags. All right, Jamaican music might be a universal set. And within that, you might have reggae music as a smaller set. Months of the year might be a universal set, and then we might have a set for just the months that start with J. So January, June, and July. Imani?
Venn diagrams. A Venn diagram shows the universal set, or rectangle, and the smaller sets, which are circles. Elements of each set are placed within the circles.
So that's what we said. The Venn diagram is a rectangle, and it represents the universal set. Within that rectangle, we're going to have some circles, each of which represents a set. Some of the circles are going to overlap or intersect. Some of the circles are not going to touch each other, in which case we say they are disjoint. You might even have a circle within another circle, in which case we say the smaller one is a subset of the bigger one, means all the elements in the smaller one are contained within the bigger one. John?
Okay, miss. Intersections of sets. When the circles overlap or intersect, it means that they share elements in common.
All right, so when circles overlap or when they intersect, it means that they share elements in common. So if an element belongs to both sets, that element will be presented in the middle, in the intersection, where the two sets overlap each other. Imani, read that for me, please.
Okay, miss. Intersection of sets.
Hold a second.
Oh,
Hold a second, Imani. Let me fix something.
okay, miss. Okay.
All right, go ahead.
Okay, miss. The union of sets. The union of a set is all the elements of that given set, or the total of elements in or the total of elements in all the sets being counted.
All right, so we have two sets, whether or not they overlap, whether or not they intersect, their union is the total of all the elements in both sets. If they intersect, it would be the elements in the intersection as well as the elements that are not in the intersection, the total of those. That would be their union. So you can have two sets that are disjoint, meaning they don't intersect. We can still have their union, just combine all the elements in each set. When we're listing the union of sets, we only list the intersection once. That means those elements that are in the intersection, we don't need to list them twice. We don't need to double them up because they are in both sets. Once is enough. We just list them. So we list the intersection as well as those elements that are not a part of the intersection. Okay, John?
Disjoint sets. Two sets are disjoint if the two sets are disjoint if they have no elements in common.
All right, so disjoint sets are shown in the Venn diagram by two circles that do not intersect. Right? They don't overlap each other. They are separate. We say they are disjoint. Imani?
Okay, miss. Subsets. A subset is formed if all the members of a smaller set are also contained in a larger set.
All right, so for the subsets, we have a smaller circle within a bigger one. And we say that the smaller one is a subset of the bigger one. All the elements in the smaller circle are contained within the bigger circle. Now for subsets, if, for example, the smaller circle is A and the bigger circle is B, so we say that A is a subset of B, their intersection would be A, and their union would be B. So think about it. You can draw it in your book. Draw a bigger circle and a smaller one inside it. So the smaller one is set A, the bigger one is set B. Their intersection, where the two sets overlap, or what is common to both sets, would be the smaller one. Because everything that is contained within the smaller one is also contained within the bigger one. So their union is the smaller one. Sorry, their intersection is the smaller one.
So you see,
Their union would be the bigger set because it already contains the smaller set. So this is actually a rule in sets. Wherever you have subsets, if A is a subset of B, then A intersect B is equal to A, and A union B is equal to U. Okay, whose turn is it now? John?
Mrs. John.
the complement of a set. The elements that do not belong to a set are the complement of that set.
All right. So when we have our Venn diagram and we have circles intersecting, them overlapping, we have some disjoints. We are asked to list ends of a set. All right. So we look carefully to see the elements in that circle. Also listing the elements that overlap with other circles. So if set A and B overlap, and we are asked to list elements of set A, we still need to list those elements that overlap with B because they are still in A. The complement of A would be those elements that are not in A at all. So anything that's not in A is the complement of A. Anything that's not in set B is the complement of set B. And complement by putting a little stroke at the top right hand side of the set. Right, Imani?
Okay, miss. The number of subsets of a set. There is a fixed number of possible subsets of any given set, depending on the number of elements in that set. It is 2 to the power of n, with n being the number of elements in that set.
Okay, read that again for me, Imani.
Okay, next. Number of possible subsets in any given set. Depending on the number of elements in that set, it is 2 to the power of n, with n being the possible number of elements in that set.
All right, so what we're saying is given any set, there are a fixed number of subsets. Yes, John, like that. There are a fixed number of subsets that the set can, and the formula to work out the number of subsets is 2 to the power of n. Now, I'm going to stop sharing for a little bit and explain to you on the board what we mean by that. All right, so, okay, so number of subsets. Number of subsets, and this is given by 2 to the power of n, where n is the number of elements in the set. So that means, let's say we have a set A And that set has members 1, 2, and 3. How many elements are in set A?
Miss, 3 elements.
So the number of subsets would be 2 to the power of 3, right?
Yes, miss.
There are 3 elements. So 2 to the power of n, where n is the number of elements. So 2 to the power of 3 give
8.
8. So there are 8 possible subsets. Let me list out the subsets. So first of all, every set is a subset of itself. So 1, 2, 3, that's a subset of itself, right? The empty set is a subset of every set. So we have the set itself, the empty set, and then we can list each element separately. And then we can combine the elements in here. So 1, 2, 2, 3, and 1, 3. So these are the 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. So this is what we mean. This is what we mean when we say that what are the subsets. This is how we write them. So using the formula, you can just use the formula, but I just decided to show you what we mean. If a set has 3 elements, it will have 8 possible subsets. And these are the 8. The set is a subset of itself. The empty set is a subset of that set. The empty set is a subset of every set. And then we list out each element singly and we pair them up. If the set had 4 elements, it will be 2 to the power of 4, which is what? 16.
Yes,
Okay, so we have the set itself, the empty set, list them out one by one, then pair them up, then put them in threes, then eventually we would get 16 in all, right? So this is what we mean when we say the number of possible subsets. If you are ever asked to draw them, to list them out, that's what you should do. All right, so let me go back to my screen. All right, so whose turn is it? Imani?
no, Miss John.
No, Miss John.
John? Okay.
Set notation. U is for universal set. E is an element of. P is a subset. U with a slash in it is not a subset. 0 with a slash in it or curly bracket, nothing in it is an empty set. Or no set.
All right, so set notation are the group of symbols that we use in sets to represent or to express ideas about the set. So mathematics has a language of its own. Just like all subjects, they have their terminologies, they have their own language. So in mathematics, we use certain symbols and they create mathematical sentences. Might not have the verbs and pronouns like the English language, but the symbols have their own character and they form mathematical sentences. Now in sets, as in any other topic in algebra, we have our symbols. So as was mentioned before, the capital U represents the universal set. And that means all the elements that are being considered. That curved E looks like a capital E, but it's not straight, it's curved. It means is an element of. So if I write 16 and put that symbol and put B, I'm saying 16 is an element of set B. The C, or what looks like a C, is a symbol for the subset. So remember, we had talked about a smaller set inside a bigger set, a small circle enclosed within another circle. The smaller one is a subset of the bigger one. All the elements in the smaller one are contained within the bigger one. So vowels is a subset of letters of the English alphabet. All the vowels, the 5 vowels, are also members of the English alphabet. Can you each give me an example of set be subset of another?
Okay, Miss.
Oh, Miss, I have one. Miss, elements in A are even numbers and subset. And the elements in B are factors of 4. Wait, no. Factors of 4. Hold on. Wait. Wait. I was
Okay,
so.
back to the drawing board. Take your time.
No, I know. Okay.
All right, go again.
Counting numbers less than 8 and factors of 4.
All right, so you're saying the bigger counting numbers less, which would include what?
Miss 1, 2, 3, 4, 5, 6, and 7.
Okay, and then the smallest set B would be factors of 4.
Yes, miss.
Which would include what?
1, 2, and 4.
Correct. Okay. So the
Miss,
factors of 4 contain numbers less than 8. You go, John. Give me some example. Give me an example of where one set is a subset of another.
Okay, Miss. Vowels. Oh, wait, sorry. Odd numbers less than 20, Miss, and factors of 2. No, wait, sorry, Miss. Factors of 20, Miss, in the subset, which would be 2.
But are all the factors? What are the factors of 20?
Miss, the factors of 20 are. Oh wait, sorry, Miss. Miss, factors of 3. Miss, factors of 3, which would be 3. Wait, no, sorry. Miss, factors of 15, actually, which would be 1.
What are the factors?
Miss, 1, 3, 5, and 15.
All right, so you're saying odd numbers less than 20 and then factors of 15. What made you change your mind about the factors of 20?
Miss, because odd numbers are numbers that cannot be even. Miss, that cannot be divided by 2 without an end.
And which factors of 20 are not odd?
Miss, right. Miss is only one of them which is odd and which is 1, Miss. Which would be, Miss, and the others are 2, Miss, 2, 4, 5, 10, and 20, Miss.
So 5 is also odd.
Yes, Miss.
Okay. All right. But So those are good examples. Can you think of any example that does not involve numbers
Yes, miss.
to show subsets?
Yes, miss. Miss, animals in a zoo that start with the letter Z.
Mm-hmm.
Miss, it will only be a zebra. Wait, no. Miss,
Okay, so
animals.
zebra would be. Are you sticking with that? Zebra must start with a Z,
No, miss.
or you want to use another letter that will be more inclusive?
Yes, miss. Miss, the letter L.
All right.
Miss, there are some lemurs in zoos and there's a lion, miss.
All right. Imani, can you think of any subsets that don't involve numbers?
Oh, okay. The islands in Greater Antilles. Oh, you could do the islands in. Let me just make sure I'm correct before I go and say something. Okay.
Miss, I have a next one, miss.
Sure.
Miss, I have a next one.
Go ahead, John.
Okay. Planets in our solar system starting with the letter M. Miss, that would be
Planets.
Mars and Mercury.
Would that be the subset or the bigger set?
Miss, the subset. Miss, the
All
bigger
right. So
set
what would
is
be the biggest?
Miss, planets in our solar system.
All right.
Okay.
Okay.
Okay,
Planets
Miss.
in
I
the
have one.
solar system, and then the smallest set would be planets that start with the letter M. All right. Go ahead, Imani.
Mrs. Khan is big, but okay. So islands in the Caribbean are countries in the Caribbean.
Islands in the Caribbean and
CARICOM countries.
oh, okay, yeah, okay. CARICOM countries. All right, very good.
Yeah.
So if a set is not a subset of another, we just put a stroke through the C to say it is not a subset. Now the empty set,
Miss, I have one.
otherwise called the null set, is represented by a circle with a stroke drawn through it or curly brackets with nothing inside. So John, you're saying you have an example of the empty set, the null
Yes,
set.
yes, Miss. Miss person
Go
to
ahead.
swim across. Miss person who swim across the Pacific Ocean, Miss.
Okay, persons who have swum across the Pacific Ocean. All right, so we know that the empty set has no possible members. So there is no one who has swum across the Pacific Ocean. That's an empty set. Imani, can you think of one?
Okay. Um. Empty sets. Okay.
If you
They.
think of something
Okay.
outrageous,
Okay. 1-year-olds that have their license.
all right, 1-year-olds who have their driver's license, that's an empty set.
Me, Miss.
Okay, very good.
Miss, can I say one?
Sure.
Miss, animals that can drive.
Animals that can drive. Yes.
Yes.
I mean, you can't tell some of the cartoon animals that do. You can't tell some of the Disney animals.
Yeah.
Okay, Miss. Miss, Zebras that can drive.
Miss, I have two
I
more.
get your point. Sure, go ahead. Go ahead, John. John, you said you have two more. Can you hear me, John?
Yes, Miss, I can hear you loud and clear.
Miss, I have two. Miss, I can hear. Miss, I can hear
Okay,
you. loud and
Amari,
clear.
go ahead.
Okay, Miss. Persons who flew up to the sun in an airplane.
Persons who have flown up to the sun in an airplane. Okay, yes, definitely that is a null set. And you said you had two. You guys are freezing. All right, in the meantime, let me read what's on the other slide. So we have two circles that are not connected in any way. They are not intersecting. We don't have one in the middle of the other. We just have two circles beside each other. And this is called disjoint sets. So disjoint sets have nothing in common. They might be within the universal set, but that's it. Other than that, no other characteristic to them. In spite of the fact that disjoint sets do not overlap, we still can have the union of disjoint sets. We simply just list out all the elements in both sets. Some persons might be tempted to feel that because the sets are disjoint, they can't have a union. That's not true. Their union is all the elements in one set and all the elements in the other set. And their intersection, though, would be the empty set or the null set. So the intersection of disjoint sets is the set or the null set. All right, welcome back, Annie. You lost it there for a minute. Welcome, Mari.
Hi, Miss.
And John.
Yeah, thank you.
All right, so we have 2 to the power of n, which is the formula for working out the number of possible subsets of any given set, which we just demonstrated on the board. 2 to the power of n, with n being the number of elements in the set. So we just demonstrated, we use as an example a set with 3 elements, and we worked out that a set with 3 elements will have 8 possible subsets, because 2 to the power of 3 gives 8. They have a complement. The complement of set A refers to those elements that are not found in set A. The union of 2 sets would be all the elements that are in both sets combined. And the symbol for that is something that looks like a U, but it does not have that little curve at the side of it. And the intersection is something that looks like an N. Also, it does not have that little curve at the top. So the union is all the members in both sets, or the 3 sets, or whatever number of sets. And their intersection is just those elements that overlap, those elements that are found only where the 2 sets intersect each other or overlap each other,
Miss,
not in the other parts of the sets. Do you
Miss,
have a question or statement?
yes, Miss, I have a statement. Miss, the statement is that if you want to do bracket Y intersect Z bracket complement, Miss, 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 that's something they can do with the intersection and the complement, Miss.
Right. So
There's nothing
A
with
intersect B complement would be those elements that are in A only. And B intersect A complement would be those elements that are in B only. All right, so you're correct. All right, here we have another slide that shows the curly brackets, which is what we use to list the elements of the sets. The diagrams below show the shaded region there shows the intersection of set A and B. So those elements that are only in that middle part that's shaded. And remember, for the subsets, if we were to shade the intersection of subsets where you have a smaller circle within a bigger circle, the intersection would be to shade the smaller circle. Because remember, if A is a subset of B, their intersection is A and their union is B. Now, the second diagram shows the union of A and B. So where A intersects B, their union would be to shade everything in A, B, and their intersection. That is the union of those two sets. All right, so here we have our Venn diagram. We put the capital U at the top to represent the universal set or all the elements being considered. In this case, we have three sets intersecting, set A, set B, and set C. So where J is, right in the middle, J is an element of all three sets.
Yes, Miss, see the intersection of all three.
All three. So J and Roy would be the intersection of A and B.
Yes,
Sorry,
Miss.
not A and B.
Wait.
C and B.
Yes, Miss. Miss.
J and Roy would be where C and B intersect.
Yes, Miss. And Roy and J and Al would be where A and B kind of intersect.
Not A. Roy is not in A.
He's not.
Roy is not in A, no.
Miss Leroy, Miss Leroy. Leroy.
So J and Roy would be the intersection of C and B. J and Betty would be the intersection of A and C. And J and Al would be this intersection of A and B. Do you agree? Do you see that? So let's go again. Where the A circle overlaps the B circle, so A intersect B would be J and Roy. Why do I keep mixing up A and C intersect B? C intersect B, that's J and Roy. A intersect B would be J and Al, and A intersect C would be J and Betty. Now, Paul is B only. If they say which element is in B alone, that's Paul.
Oh, yes,
Paul is not overlapping with any other circle.
Miss Leroy.
Leroy is A only. You see that, Leroy?
Yes, Miss.
Yes, Miss.
Yeah, Leroy is A only. So what about Anne?
Miss Al.
Anne, A-N-N.
Oh, Miss. She's not in any set. She's complement union C complement.
Right. So A union B union C, all in brackets with a complement with a little stroke on top. That would be Anne. She's not in any of the three sets. However, she is in the universal set. All right, so looking at this last diagram, this is the last diagram we're going to be contemplating. Now, we have several sets here. We have set A, set B. Okay, you guys internet giving problems.
F, G.
A, set B, set C, D, E, F, and G, right?
Yes, miss.
Yeah. You guys keep getting off. Your internet is playing with you. All right,
Yes.
so hush, we're on the verge of wrapping up anyway.
Yes, miss.
Where set A, B, and C intersect, that's the shaded region there in the middle. If you look at
it
set
looks so
F
weird, but
and
it
G,
makes sense.
right, so A, B, and C, they intersect there in the shaded
Yeah.
region. If we wanted to show the intersection of sets F and G, we would just shade set G,
Yes, miss.
since it is a subset
You
F,
mean E and
right?
T, miss? Oh, yeah, don't worry.
Yeah, G is a subset of F.
Yes, miss.
So you
So the
just say
intersection.
G because that's the intersection.
So the intersection of G and F would be to shade G.
Yeah.
D and E are disjoint.
So there's
They are disjoint, don't
Or
overlap.
intersection.
there's no common pair of them.
Miss, the union is
Right.
D and
So
E,
their
miss.
intersection.
Miss, I was saying that,
Yes,
that the
John?
union is D. Miss, I was saying that the union is D and E.
Right. Their union would be till elements in D and all the elements in E. And their intersection would be
The
what?
empty or null set or the
The empty
disjoint
set.
sign.
Right. The empty set or the null set. So the intersection of disjoint sets is the empty set or the null set. So those are the common ways that you will see sets represented. Either you'll see them one or two, not one, sorry, two or three sets intersecting each other, overlapping, or they can intersect like subsets where one set is contained within the other set, or they might intersect at all, in which case they would be disjoint. And remember, we can have elements on the outside of the circles, elements within the rectangle, but not in any circle, but still a part of the universal set. And if it's the case where you are given the number of elements to work with, you would still have to add those elements that are in the rectangle but not the circle. You'd have to add them to get the total for the universal set. So as we go along in sets, we're going to be finding the intersection if it's not given, or finding the union, or finding action of the Venn diagram,
Miss, the
the number
subset.
of elements in any section based on what we are given. So some algebra is going to come into play, because ultimately we are going to be left with an equation with an unknown, usually x. And in solving that, then we can plug in and work out the other sections of the Venn diagram. So this is our introductory class to sets in the topic by topic. We have looked at the terminology used in sets. We have looked at set notation, at least the basic set notation. There are other symbols using notation that we haven't touched on, but we look at them, we go deeper into the topic. So next week, Wednesday again, we'll continue in sets. Thank you, scholars, my live studio crew who are always willing and very able to help me. Thank you for your company tonight. Thank you for those on the chat and those joining in via YouTube, Facebook, Twitter, um,
Social
media.
accounts.
So join. Remember, tomorrow is Thursday at
Midnight oil.
midnight oil. Yes, our midnight oil class tomorrow night at midnight. And we are going to have
We'll
our
have
formula
tonight.
class. So our formula class will be from 8 to 9. And then we're going to rest up and refresh and come back at
For the
midnight
midnight oil
tomorrow, where
class.
we're going to do some multiple choice. Yes, multiple paper one, CSEC paper one. Last week
We're
we did
aiming
20
for 40 questions
questions.
this week.
This week we're going to go for
40.
40 questions. We're going to try to get 40 questions. Hi, Zion. Good. We'll see you students tomorrow. Take care and night. Enjoy your sleep
Thank you, Miss.
and
Good
dream
night.
of me if you may. Good,
Miss Live. Live, Miss.
good night,
Good night,
scholars. I'll see
everyone.
you
See
tomorrow.
you in the next video.
Good night.